Okay, so class. Okay, let's try it again. Angel.
What?
Rafa.
Yes, sir.
Brooklyn. How we doing? All right, so we are going to finish up these notes, but it's going to be a very abbreviated part of these notes. Very abbreviated part of these notes, okay? So I would like for you guys to actually start working on this. Working on this homework that goes along with this. So today, hashtag what? 43? 43? You guys agreed, 43?
Yep.
Okay, today's date?
2020.
Now, it reads, a business owner opened 2 different types of investment accounts at the start of the year. The function f and g represents values of the 2 accounts as a function of the number of months after the accounts were opened. Months. Okay, so here's some true statements about the investment accounts. What does each mean? So first, this one right here. What does the alligator always eat? Bigger number, right? Alligator eats a bigger number, right, Luis? Okay. All right, so which one's going to be the bigger number? F of 3. So now, but in terms of the problem, what does that mean? At 3 months, account what?
Open.
Okay, so 2 different investment accounts. So account F is greater than G, right?
Is that is or five?
Is. No, because I traced back over it again because it's a is.
I could have sworn you put a number. You didn't even spell that right. You put D6, T6. My niece can write better than that.
I'm bagging on you.
Oh, that's
So on B, what does B mean?
Yeah.
Okay, so what does that mean though? G of 6 is greater, so
6 months the account G has a greater value.
okay, yes. So at 6 months, account G is greater than F. Now, what is this last thing saying? The functions are equal. The functions are equal, so we should be starting at the same point. Okay, should be starting at the same point. Yeah. It's not going to be 0 because this is going to be investment account, so it's got to start with some principal. There's got to be a principal amount first. Yeah. So that would be my P value. And if P is 0, anything times 0 is 0. So no matter what the growth is. All right, says, if the 2 functions are graphed on the same coordinate plane, what might this look like? Sketch 2 functions. Now, I'm going to show you guys. We're going to do a graph like this. 0 months. 1, 2, 3, 4, 5, 6. And because we do not know the amount of money. Okay, we know that going this way, this is months. And the amount of money, this would be going up, right? So I'm just going to put $sign here. So let's go. I'm going to put in some numbers to make this a little bit more. So 100, 200. So in relation to money, you guys can see that it is getting bigger. So the amount of money is actually going up. So I'm going to make a table out of this. So I had some colors, but I guess they are gone now. So let's see. Yes, I do have a black one. So we know at 3 months, f is greater than g. So I'm going to say that function f is black. And you guys could actually, this is going to be for those people out in YouTube land. Okay, f is going to be black for this case, and g is going to be blue. So f is greater than g at 3 months. So let's go to 3 months. F is greater than g. So I'm going to put a number there. I'm just putting it here. So all I know is f is going to be greater than g. So where does f have to go here? Where does f go here? Somewhere above it, right? This is the first one. This is 3 months. So look, f is black because our first statement at 3 months account f is greater than g. Right? So the black one is going to be on top of the blue one here. Okay? So now the next one says at 6 months account g is greater than f. So g is greater than f. So I'm going to put a point for f for 6 months. I'm just picking a number. All I know is all the accounts are going up. So I'm just going to make this one go up here. And where does the blue one have to go? On top, right? Because it's greater. It's some point up here. Now, I'm just going to connect the dots. We're starting at the same point, so I'm going to say that they're going to start at 100. Draw a line there. And now for this one, starting at the same thing, right here. So you guys could actually see what this is doing. Now, we have been doing a lot of this lately with the two graphs. What did I tell you guys that we should do if we're doing the two graphs? We could do a vars, right? And what would this thing right here be called? Yeah, intersection. Where we would graph it and do an intersection. So we have a graph of my two functions here. We know that this one from here to here is going to be above, but at some point there's an intersection that this is now going to change to be above. So it's just asking you to sketch these. So your drawing doesn't have to be as great as mine. Yeah. So people hating on my drawing skills. But, I ain't mad. It's all right. You didn't hurt my feelings. I'm good. I'm good. All right. Let's take a look here. It says bacteria in different conditions. To study the growth of bacteria in different conditions, scientists measure the area in square millimeters occupied by two populations. The growth of population A in square millimeters can be modeled by f of h, there it is, where h is the number of hours since the experiment began. The growth of population B can be modeled by g of h, and there's your function. Here are the graphs representing the two populations. All right, we got the two populations. In this situation, what does the point of intersection of the two graphs tell us? In this particular situation. Okay, F5. F5, what? F5 hours what?
Intersect.
Okay, but now, in this situation though. There, that's what I needed. The populations at 5 hours, the populations will be the same. Okay. Now, suppose the population coordinate of the point of intersection is 171. Explain why we could find the corresponding time by this. So I know that both of them are going to have the same value, right? So we're going to do this mathematically. Right now we just did it from the graph. Now we're going to do it mathematically. So I'm going to start with the f of h. So my function for f of h starts off with 24 times e to the 0.4 h. And that right there, I'm going to set equal to 171, right? 171. So let's go ahead and let's try and solve for this. So to solve for my h, to get an exact value for h, divide by 24. It's not going to come out evenly. So I'm just going to leave it as a fraction. So I'm going to get e to the 0.4h is equal to 171 over 24. Okay, and now we're going to what? ln. Very good. We're going to ln. So it's going to be ln of 171 over 24 is equal to 0.4h. Am I done? What do I want to do here? Divide both sides by 24 here, right? Or 0.4. Divide both sides by 0.4. I said 24, didn't I? Uh-oh, sorry. Yeah, it was 0.4. I meant 0.4. Okay. So h is going to be about... Oh, good job. All right, so I'm going to put it on my calculator so you guys could actually see this. A couple people were having trouble with it earlier, so I want to make sure you guys actually do see what we got here. So I'm going to go control divide, and it's going to be ln of 171 over 24 divided by 0.4. So it should look like this. So we get 4.9 hours, right? So what does that tell me about my first problem? Yeah, but what does it tell me about first one though? Were we correct?
Yeah.
Kind of. Right? 5 is close. Okay, but we're pulling it off a graph. But to be more exact, we know at 4.9 hours. All right, so now, okay, do I need to solve it for the other side also? No, why? They're both equal, right?
Yeah.
They're both equal. That's where they are crossing. So both of them are equal. Both are equal. So I really don't have to do much more for that. Okay, so like I said, I'm abbreviating these notes.
And it says show your reasoning. If it were to just look up, you wouldn't have to, right? On the test.
So one way of doing it is graph. What did we do here? We just did all the work on it already. So we basically answered everything here. And we're saying both are equal, and then we can graph it if we need to, but we've already proved it. Okay, this is the math for that.
So let's say you give us this kind of like exact same question on the test.
Okay, you're gonna show me. Okay,
Work, right?
I'm already telling you because yes, there is one like with a graph with a bunch of parts like this. Show me the work. If you show me the work, that's gonna take care of almost everything.
Okay.
Yes, step by step. You know, don't just, you know, throw it in the calculator and give me a number. But we could do that also. We have problems that you can do that. All right, so we're going to do this one right here. Okay, so let's take a look. For 16.3, it says population to countries. So the population in millions of country C is given by this equation F. Population country D is given by equation G. Both equations, T is the number of years since 1980. Will there be a time where the two populations are equal? Explain your reasoning. Okay, so what could I do to figure it out? I can. Let's go ahead and do that. Let's go ahead and graph it. We have two equations, don't we? Okay, since we have two equations, so it's going to be my F1 and F2, right? So on my graph is where we're plugging it in. So I'm going to my scratch pad. Here's my graph. And I have 16 times e to the 0.02x. Tab. Now I'm going to enter my other one, which is 17.5 times e to the 0.025 x. Yep. All right, hit enter. Now we got to figure out what? Windows. All right, so if we're starting with the year 1980, how many years do you think we should actually use? You want to do 10? We could do more. So what about present day?
30? Oh, so 40?
We could use 40. That's all the way to present day, right?
Yes.
Okay, so that would be a good way of doing it. So let's look at our windows. So are we going to use negative numbers? No. So my first value should be 0, because my initial starting is 1980. And we said what for the years? 40 years, right? That gives me all the way to 2020. What about my Y value? Start at 0, because I'm not going to get negative population. Only negative population are sleeping in my math class. Ah, see what I did there?
Yeah.
Okay. All right, and what do you think the range of this? Okay, what does the Y represent here? It's my population, right?
Yes.
It's population in millions. Okay, so I can start at 0. I can start at 0 because we abbreviated for this because each one is referring to millions. And then my max, I know that my initial population of country D is 17.5.
Let's say 100 million.
You want to put it to 100? We can do 100. There you go.
That's a lot of zeros.
Because each one represents a million. Hit OK. There you go. All right.
Now we can parse it.
Will there be a time where the two populations are equal?
Yes.
No.
Mr. Brown says no.
No, wait, 10.
Oh yeah. Stop doing that.
There will be a time.
There is? When?
You just. Well, no, on this right here, there is. On this one.
Okay, what window has, what's the time? It'd be a negative time, wouldn't it?
Right.
Yeah, so we're not dealing with negative time, are we? So we're starting at 1980. So this one's going to be no. I could say the graphs do not intersect.
You put the whole.
The graphs do not intersect. So at some point in time, the population country C reached 30 million. When does this happen? So now, the population, we want the total population to be 30. How can I put that in my calculator? No, because that if I do VARs, that enters the year. I could do that, it's just going to take me a while. Can we enter another value? Right, Joseph? Please don't. So I'm going to hit tab. And this is going to give me 30 million. So if you look right there, there's my 30 million. I hit tab and I entered another value. So there's 30, which is representing 30 million. And the question says, country C. Which one is country C? Is that my F1 or my F2? Is it the first one or is it the second one? It's the first one, isn't it?
Yeah.
My first one in this case is blue. And what am I looking for now? Intersection. So let's go ahead and find the intersection. So menu, analyze, intersection. Now, it brings up a question. It says, which graph? So click the blue one, because that's going to be the one that I'm looking for. And the second graph. So it means, where is it intersecting? Or what am I intersecting with? So I'm going to click the black one right here. Lower bound, upper bound. So that's going to tell me that it's going to be Can you please stop, Brooklyn?
That wasn't even me.
It wasn't? It was Desiree?
No.
Shame on you, Desiree. Seriously. I asked nicely. 31.4. Okay, what's my answer going to be in context? 31.4 years to do what? Oh, very good. So I wrote it out right here. So right here, 31.4 years to reach 30 million. Okay, like I said, I'm abbreviating the notes. That means I'm skipping a lot. It's the same thing that we keep doing over and over and over again. If you know how to use a calculator, you're going to be great. If you don't, because you sleep during my class, All right, don't forget, like, share, and subscribe. Hit that notification button.